Hi everyone, in this video we are looking at a review of geometric reasoning. So just being able to recall geometric facts and important information that's going to help you with the next couple of lessons. So to get us started with, a proof is an argument that you're trying to support, and then you've got your theorem, which is like all the geometric reasoning that we're talking about, things about angles in a straight line, shapes, and all of those other kind of bits of information you need to be able to recall, and then the symbols that are associated with that. So you need to be able to use the appropriate symbols at the appropriate time. We have covered this in class, so this video is just a complement of already that. So if you have a look at these two shapes here, labeling the triangles, so you would have your triangle would be labeled, in this case, triangle A, B, C. So using your triangle here, and this one would be labeled triangle, triangle D, E, F, and so forth. So there you go, using those kind of symbols to label certain things, or in this case, parallel lines. So we've done that. That's what you would have using your symbols. So looking at the geometric theorem recall that we need to remember, you've got all these words here, so you should be able to recognize what those things are. So I would recommend that you organize these in a way that suits you. You might want to start off with the basics like the angles in a straight line and a point and so forth. So angles in a straight line are 180 degrees or supplementary. Angles in 90 degrees are complementary, so they add up to 90. Vertical opposite angles are equal, and you've got angles in a point equal to 360. So we know that these four angles would add up to 360 degrees if we calculated them or found them. And so because of that, you've got, that's because of straight lines, so they're things to remember. Now, if you have two parallel lines and you cut them with a transversal, so that's your transversal, they're going to follow a certain set of rules. So your angles that are inside are co-interior. That's what this one means here. So they add up to 180 degrees. And that's because if you have a look here, these two angles are alternate. So this rule here, and they opposite sides are, opposite angles are equal. And then if we use a different color, these angles are alternate, and because this is a straight line, there has to be 180 degrees. So, and then same over here. So by process of deductive reasoning, we can determine that these guys are together are 180 degrees. And if we start to see that, again, if this is a straight line, that's an angle which equals this, it therefore has to equal the same here. So that's why it's called corresponding. Now, please go back, have a look at, this stuff here is year 7 work. So if you can go back and look at parallel lines, that might help you refresh what all this means. So you might hear me say the fuzz or the fun rules, and that's because of, it looks like an F, this is a U or a C, as you can see here, and the Z or N, depending on which way you look at it. Cool. So we've got those. So using your geometric reasoning to do a straight lines, pause the video and have a go of these questions here. All right, so triangles. The angles add up to 180. Equilateral and isosceles triangles have their own special properties. You'll see that they're color-coded here for your convenience. And the last one we have here is your exterior angles of a triangle. So one exterior angle will add up to the sum of the other two, will equal the sum of the other two angles within the triangle. And that's because those three angles are going to be 180 degrees. Is for those three angles, and in a straight line it's 180 degrees. So if you're taking one angle away from that in your triangle, so here's our M, if you're taking away this one here, so let's just call this A, B, C, this is 180. So by elimination and deduction, by deducing it, you have this has to equal 180. Sorry, has to equal those. Sorry, A and B has to equal M. In like you to pause the video and have a go of these ones. I'll actually do the first one here for you. So if we do 7 here, we're going to use the rules. So we've got M, we need to find that, but we don't have this angle here, which we know would be 180. But we do know that this is an isosceles triangle, so 2 equal sides because of these little markings, which means that these angles here, I'm going to call them angle A, are equal. So to find A equals 180 minus 52. Now that would give me a value, but for 2 angles, but I know that these are both equal, so I can divide this by 2 and that'll halve it for me, and that will give us A equals 64, and that's because of an isosceles triangle, isosceles. And then the next one is going to be M. So to find M equals, sorry, normally I would put that straight underneath, but I'm just running out of a bit of space. M equals 180 minus A. Substitute M equals 180 minus 64, which gives us 116 degrees. So M is 116 degrees, and this is a straight line. So using that reasoning to help you solve those questions. Pause the video, have a go. So here we go, we've got quadrilaterals. So quadrilaterals are 4-sided shapes, 4-sided polygons, sorry. So quadrilateral equals 4-sided polygon. They're regular, irregular, and those that are parallelograms have certain rules. Squares and rectangles have more specific rules. Any bisecting, any diagonal in parallelograms is always bisecting. In parallelograms. So that means that when I have a line, so I'm just going to grab this one here and draw a line. If I take a line, it's not going to be perfect. This will always be, and I take another line from the other side, regardless of which parallelogram I'm using, it's always going to be the same. It's always going to be a bisect. So they're going to cut each other in half. More specifically for your rectangles, when you have that, your diagonals are equal. So if I was to draw a line here, from corner to corner perfectly, I know I'm not doing a great job of it, these parallel lines would, these diagonals are equal. You do the same thing to a square, they're going to be equal. And the other thing to note is that your diagonals for squares bisect, so they're still cut in half at 90 degrees. So when I'm just going to draw this in haphazardly, that is going to be 90 degrees for all of them. And the other thing to note is that they cut the corner or bisect the corner angle. So if that's 90 degrees, if you're bisecting, we're cutting it in equal halves. So that means that the angles will be 45 degrees. These are just something that you can be, so that's 45 degrees, 45 degrees. Now if we do the same thing at the rhombus here, those diagonals are 90 degrees. So when they bisect at 90 degrees, diagonals, and that means that these angles here are going to be equal. So I'm just going to call it, I'm going to color code them, that you've got this angle is the same as this one, which means that this one is the same as this one. And this one here, let's give it a pink color. This angle is the same size as this one and these ones. So that helps with like your geometric reasoning and deductive geometry. So using that, you know that there is 360 degrees in your angles. And when you add up the sum of the angles in your quadrilateral. So using that here, we know that this is an exterior angle. So that's 180. So this angle, let's call it x. X equals 180 minus 60. I'll give you 120 degrees. This is 90 because of this symbol. And so angles in a parallelogram, so y equals 360 minus 120 plus 90 plus 85. And that's because if these add up to 360, if I have 1, 2, 3 angles, I can now deduce what the fourth angle is, which is y. So this is because of a quadrilateral. And this would be a straight line. So using that, try and solve for m and x and z, and pause the video and have a go of those ones. Alright, all good. All the best with your previously on geometry recalling of important figures and facts.